Cardiac cycle. Let us first review the anatomical structure of the heart. It is a four-chambered structure, as you can all see. The two atria separated by the two ventricles. The four major valves are also visible in picture. The two atrioventricular valves, the tricuspid valve on the right separating the right atrium from the right ventricle, and the mitral valve on the left separating the left atrium from the left ventricle. Also the aortic valve at the base of the aorta arising from the left ventricle, the pulmonary valve arising from the base of the pulmonary artery which arises from the right ventricle. Moving on to the conduction pathway of the heart, it is a sinoatrial node which is the pacemaker of the heart, located at the roof of the right atrium where the superior vena cava drains. It is from here that electrical impulses travel from the right atrium to the left. The movement of electrical impulse is from the sinoatrial node to the atrioventricular node to the bundle of His, which is in the interventricular septum, followed by the ventricular muscles, the Purkinje fibers. So, electrical impulses follow this path from atrial depolarization. It continues on to ventricular depolarization, followed by ventricular repolarization, leading to the cardiac cycle. So, the cardiac cycle is basically a chain of events from the beginning of one heartbeat to the beginning of the next heartbeat, which comprises of 7 phases, of which systole phase or the contraction phase lasts for a mere 0.3 seconds and the diastole or relaxation phase lasts for 0.5 seconds. The details: atriosystole, the atria contract, mitral valve being already open, the blood passively flows into the ventricle. During this phase, contraction of the atrium tops up the ventricular volume while the ventricles relax. So blood flows into the ventricles. Next is the isovolumetric ventricular contraction. When the left ventricle begins to contract, there is increased in left ventricular pressure. The atrioventricular valves close, the mitral valve closes, while the ventricular volume remains the same as the valves are closed. So it is isovolumetric ventricular contraction. Next comes rapid ventricular ejection. The ventricles meanwhile continue contracting when the pressure is increased such that it exceeds the aortic pressure. There is opening of the semilunar valve, namely the aortic valve, and most of the stroke volume is ejected during this phase, leading to reduction in the left ventricular volume. Next is a reduced ventricular ejection phase, when the ventricle has already released so much blood that the ventricular pressure falls, the aortic pressure falls, and the remainder of the left ventricular volume is ejected due to kinetic energy with a reduced rate. Then comes the isovolumetric ventricular relaxation. When the left ventricle relaxes, there is reduction in pressure of the left ventricle, aortic valve closes, and the left ventricular volume is constant. So it is isovolumetric ventricular relaxation, followed by rapid ventricular filling. Now the left ventricle is relaxing and the left ventricular pressure has fallen. So the mitral valve opens and the left ventricular volume increases rapidly as blood flows from the atria into the ventricles. Then comes the reduced ventricular filling. The diastasis phase is the longest phase of the cardiac cycle, and the final portion of ventricular filling, which is a very slow rate when the left ventricular volume gradually increases. So the phases of the cardiac cycle, a summary: atrial systole to start with, and there's the P wave in the ECG due to atrial depolarization, followed by ventricular systole, which gives rise to a QRS complex of ventricular depolarization on the ECG when the atrioventricular valves are closed, followed by the ventricular systole when the semilunar valves open and blood is ejected out. So ejection begins. So ventricular repolarization gradually begins, when there is the start of ventricular diastole, semilunar valves, that is the aortic and the pulmonary valves, close, blood again flow into the atria. Then comes the late ventricular diastole or diastasis phase, when the chambers relax and the blood fills the ventricles passively. So this is a summary of the cardiac cycle, and the heart sounds as audible in the cardiac cycle are lub and dup. The first heart sound marks the beginning of ventricular systole. It's related to the closure of the mitral and tricuspid valve at the beginning of ventricular systole. The second heart sound, dup, marks the end of the ventricular systole, related to the closure of the semilunar valves, namely the aortic and pulmonary valves. Thank you so much for your attention. Thank you.